To Space Launch Complex 37 and made it to the Delta IV launch vehicle on May 5th. In preparation for launch, the Mobile Service Tower, or MST, was rolled back approximately 34 hours ago, revealing the Delta IV launch vehicle. The 33-story MST weighs over 9 million pounds and is rolled to its launch position 300 feet north of the Delta IV launch vehicle. The Delta IV stands 206 feet tall, or about 20 stories, and weighs approximately 721,000 pounds fully fueled. The Delta IV delivers more than 821,000 pounds of thrust off the launch pad, and approximately 4 minutes later, at stage separation, it weighs just 20% of what it did at liftoff. For those of you watching the broadcast, you're looking at some video taken yesterday at Space Launch Complex 37. This is Delta Mission Control at T-minus 4 minutes and holding as we continue our progress towards launch at 8:03 p.m. Eastern Time. The animation you'll see after liftoff is referred to as Satellite Toolkit, or STK. STK uses real-time telemetry data during the flight to track the path of the launch vehicle beyond the range of ground-based cameras. While the team completes final preparations, let's take a closer look at tonight's flight.
The following profile details the important events of this mission using approximate times. 5. We have ignition of the RS-68 main engine. 2, 1, 0. Liftoff. The RS-68 main engine and 2 strap-on solid rocket motors ignite to lift the Delta IV vehicle away from the pad. Shortly after liftoff, Delta begins its initial pitch and yaw maneuvers to attain the proper ascent profile and minimize aerodynamic loads. Delta IV reaches Mach 1, the speed of sound, at 47 seconds. At 61 seconds, the vehicle reaches maximum dynamic pressure. At 1 minute 40 seconds, the solid rocket motors are jettisoned. Approaching main engine cutoff, the Delta IV is burning propellant at a rate of approximately 1,050 pounds per second, flying at more than 84 miles in altitude, 211 miles downrange, and traveling at nearly 11,500 miles per hour. Main engine cutoff occurs just over 4 minutes into the flight. 6 seconds after main engine cutoff, the first stage is jettisoned. Second stage engine ignition takes place at 4 minutes, 28 seconds into the flight. At 4 minutes, 38 seconds, the payload fairing is jettisoned. Following the first cutoff of the second stage engine at just over 15 minutes, the mission enters a 3-hour coast phase. At 3 hours, 3 minutes, the second stage engine is restarted for a second and final burn. Following a 2-minute burn, cutoff of the second stage engine occurs. At 3 hours, 16 minutes, the second stage releases the GPS-IIF satellite for the United States Air Force.
ALC, start T4 master script. Master script running. Establish T4 status screen cleared.
This is Delta Mission Control at T-minus 4 minutes and holding. Today's flight is the 53rd launch of an operational GPS satellite since the first lifted off from Cape Canaveral on February 14, 1989, riding atop the inaugural Delta II rocket. Over a span of 20 years, ULA's Delta II launch vehicle delivered the first 48 Global Positioning System satellites into orbit. With the debut of the 2F series, the next generation of GPS satellites, ULA's larger and more powerful Delta IV and Atlas V evolved expendable launch vehicles were called into service. To date, 4 GPS-IIF satellites have launched on Delta IV launch vehicles and 1 on an Atlas V launch vehicle, demonstrating the mission capability and manifest flexibility that ULA provides.
L minus 10 minutes. All communications switch to channel 1. All personnel and visitors remain in present position until launch. Maintain operational silence in the LCC.
Terminal count briefing. If a condition exceeds a launch constraint any time after the terminal count status check, the observer shall announce hold, hold, hold on channel 1, identify their station, and briefly state the reason for the hold.
L minus 9 minutes.
LCFMA primary wind load relief file has been loaded into the RIFCA and verified. Internal checksum is Foxtrot 4 Delta 7.
Roger. All steps are complete prior to the status check.
LCRC-1.
This is Delta Mission Control at T-minus 4 minutes in holding. We remain in the planned 45-minute built-in hold as preparations for the launch continue. Launch conductor Ed Kidda will poll the launch team in a few moments for the final go to resume the Delta IV launch countdown. 31 engineers and managers will be polled for system status and readiness to proceed with the launch. This is the final status check before launch for all Delta vehicle systems, ground systems, the spacecraft, and the U.S. Air Force Eastern Range. The vehicle system readiness poll includes electrical systems, hydraulics, pneumatics, propulsion systems, flight control, and propellants. Final processing steps just prior to launch include completing propellant topping of both vehicle stages, securing propellant tanks, and pressurizing tanks to flight pressures. Let's listen in as Ed Kidda performs the final polling of the launch team.
L minus 7 minutes.
Status check to proceed with terminal count. MEQ.
Go.
MEA.
Go.
HYE.
Go.
LOX 1.
Go.
LOX 2.
Go.
VP.
Go.
P&E.
Go.
BP.
Go.
ATC 1.
Go.
PEA.
Go.
Fuel 1.
Go.
Fuel 2.
Go.
TM 1.
Go.
ATC 3.
Go.
TM 2.
Go.
FMA.
Go.
VE.
Go.
EEA.
Go.
GE.
Go.
SYS.
Go.
DSE.
Go.
Timer.
Go.
ECS.
Go.
QE.
Go.
USO.
Go.
OSL.
Go.
VSC.
VSEs go.
ALC.
ALC. Go.
AC.
ACs go.
RC.
Clear to proceed.
LD.
Launch vehicles ready to launch.
MD.
This is the mission director. You have permission to launch.
Proceeding with the count. MEQ. Establish swing arm lock pins pull.
Active.
SYS. Establish record on change list activated.
Activated.
L minus 6 minutes.
Polling is complete and the launch team has given the go for launch. The countdown will resume approximately 2 minutes from now. At T-minus 4 minutes, and counting, the team will enter the terminal count and begin securing the second stage liquid oxygen tank. At T-minus 3:32, the CBC liquid hydrogen and liquid oxygen tank securing is started, which includes closing the propellant fill and drain valves. Also at T-minus 3 minutes 32 seconds, vehicle transfer from ground facility power to its own internal battery power will be completed. At T-minus 3 minutes, the vehicle ordnance system will be armed and the CBC liquid oxygen and liquid hydrogen propellant tanks are verified to be at flight pressure and flight level. At 2 minutes prior to liftoff, the team will verify that the hydraulic system is pressurized and confirm CBC, second stage, and FTS battery voltages. At T-minus 1 minute 20 seconds, the team will begin securing the second stage liquid hydrogen tank. At T-minus 60 seconds, the eastern range readiness is verified. At T-minus 50 seconds, the second stage liquid hydrogen tank is secured at flight level. At T-minus 15 seconds, the ROFIs, or sparklers, are ignited to burn off excess hydrogen at the base of the vehicle. Liftoff will occur at T0. This is Delta Mission Control at T-minus 4 minutes and holding. We anticipate picking up the launch count in just a few moments.
T-minus 4 minutes and counting.
Upper stage lock securing started.
The countdown clock has resumed and we are go for launch at 8:03 p.m. Eastern Time.
T-minus 3 minutes 32.
CBC propellant tank securing started.
Vehicle transfer internal complete. Second stage lock configured for flight.
T-minus 3 minutes 14.
CBC pre-press started.
3 minutes 7.
CBC lock secure. CBC LH2
T-minus
secure.
3 minutes.
Vehicle ordnance arming. Vehicle ordnance armed. CBC locks at flight pressure and flight level.
T-minus 2 minutes 30 seconds and counting. The countdown is on track and we proceed towards T0.
T-minus 2 minutes.
GPA script running.
Hydraulic press at 4,000. CBC LH2 at flight pressure and flight level.
T-minus 1 minute 30 seconds.
T-minus 90 seconds and the launch vehicle, payload, ground systems, and eastern range are all go for launch.
T-minus 1 minute 20 seconds.
Upper stage LH2 securing started.
T-minus 1 minute.
Engine
T-minus 1 minute and counting.
status.
Range green.
T-minus 50. 45.
Launch enable, GE, main power off.
Main power off.
40.
Upper stage LH2 secure at flight level.
30.
Status check.
Go Delta.
Go GPS. Springboard.
25.
Flight lock-in.
23.
SRM TVC blowdown.
15.
Rough ignition.
This is Delta Mission Control at T-minus 10, 9, 8, 7, 6, 5. We have ignition of the RS-68 main engine, 1, 0, and we have liftoff. Liftoff of the United Launch Alliance Delta IV rocket carrying the 6th GPS-IIF satellite for the United States Air Force. The Global Positioning System provides worldwide positioning, navigation, and timing services for military and civilian users. You're now hearing the voice of Tim Holt providing launch vehicle ascent data.
Vehicle control appears nominal. Mach 1. Max Q, the vehicle's flying through the region of maximum aerodynamic pressure. The vehicle is 8 miles in altitude, 22 miles downrange, traveling at 1,270 miles per hour. Solid rocket motors starting their thrust tail off. Solid motor jettison. Vehicle is transitioning from load relief guidance to powered flight guidance. ACS system is being pressurized. Vehicle is now 30 miles in altitude, 75 miles downrange, and traveling at 3,500 miles per hour. Vehicle control looks good. Starting RL10 boost phase chill. We have LOX pre-start and fuel pre-start. RS-68 throttle ramp down in preparation for MECO. We have MECO. Stage separation. Nozzle deployment. Ignition. And full thrust. At payload fairing jettison. Vehicle is now 110 miles in altitude, 500 miles downrange, and traveling at 11,690 miles per hour.
This is Delta Mission Control at L plus 5 minutes 19 seconds. We've just heard Tim Holt report the successful execution of the events comprising the early portion of this evening's mission. The Delta IV second stage and GPS-IIF satellite are traveling over the Atlantic Ocean in a northeasterly direction up the east coast of the United States. The mission is now in the first of two planned RL-10 second stage engine burns, and all systems continue to operate nominally. This burn will last approximately 11 minutes. I'm now joined by Lieutenant Mark McCulloch. Lieutenant, thanks for joining me.
Thanks, Steve. It's an honor to be back here for the launch of the 6th GPS-IIF satellite.
Thank you. And what is the current status of the GPS-IIF program?
The 2F program is in the final stages of delivering the remaining satellites. Currently we have 5 satellites on orbit, meeting all mission requirements. We just witnessed the launch of the 6th 2F satellite. We have planned for the 7th satellite this summer, 31 July, and we have 4 satellites in storage at the Boeing facility in El Segundo. And to round out an even 12, our last satellite will be delivered later this year, and we plan to launch all these vehicles by the end of 2016.
Well, with the legacy systems currently on orbit remaining functional a lot longer than anticipated, how does this affect the 2F satellites?
That's a great question, Steve, and you're right. The legacy systems, the legacy satellites are lasting a lot longer than their design lives, which is kind of attributed to the quality systems engineering as well as the mission assurance that went into the vehicles throughout their entire designs. But what the GPS-IIF satellite brings to the table is enhanced capabilities in the M code for the military users, as well as enhanced civil codes for the civilian users for higher accuracy.
Lieutenant, how did you come to join the Air Force, and can you provide us with some background information on how you got your position?
Of course. So I joined the Air Force through the Reserve Officer Training Corps, otherwise known as ROTC, and it's just one of the many avenues that you can join the Air Force. But I chose that way because it gave me the opportunity to be a college student, as well as give me the military training to be able to survive a military life. And so when I was in college, though, I learned that I liked getting to know how things worked and getting to get into the details of things, and that led me toward a degree in engineering. And with that degree in engineering, as well as my desire to work at Los Angeles Air Force Base, led me into this job now as a launch integration engineer.
Lieutenant, how does your job help the GPS mission?
So let me first start by explaining to you where I work. I work at the Global Positioning Systems Directorate, which is the Department of Defense acquisition office for all things GPS, which includes satellites, ground systems, and military user equipment. We're responsible for the acquisition of GPS, and our mission is to provide reliable, sustainable GPS capabilities to our American warfighters, our allies, as well as our civilian users. And this is done by maintaining GPS capabilities and performance, as well as fielding new capabilities and developing more robust capabilities for the future. And what my job specifically is, I'm a launch integration engineer, and I work with I actually lead a team of government and military personnel to seamlessly integrate the launch vehicle and the space vehicle all the way through launch for a mission success.
Well, since most people seem to know about GPS in their cars or handheld electronic equipment, question would be, how much more widespread is the GPS application?
So, like you said, there's there's the phones and everything like that, but some of the ways that people may not know about include banking and computer system synchronization and actually power distribution systems all use GPS as a timing device, and the timing is so precise and accurate they can actually sync things all the way across the world using that precise time. And then other ways that GPS is used is through disaster relief and search and rescue, and GPS has enabled search and rescue to be faster reacting, to be able to find people quicker. And then actually on the military side, we use GPS, and GPS has proven to actually be providing more mission success, and actually we can limit the amount of civilian casualties by using GPS.
Well, when did GPS become widely available for consumers?
So GPS, we actually started launching GPS satellites back in late 1980s, early 1990s, but we didn't actually reach full operational capability, which means 24 satellites on orbit, until 1995. And when we reached that, you actually didn't see anything very much on the civilian side until after 2000, when President Clinton actually made the direction to remove selective availability, which enhanced the civilian side to a very precise accuracy, and which has driven a lot of the changes and a lot of the developments that we see today. And it's an honor to be a part of a program and to work for something that for a service that's provided globally.
Well, Lieutenant, that's a lot of great information. I want to really thank you for joining us here tonight.
Thanks, Steve. My pleasure.
Okay. This is Delta Mission Control at T plus 10 minutes 39 seconds. We're approaching the end of the first of two planned RL-10 second stage engine burns. The Delta IV and GPS satellite are flying over the North Atlantic Ocean, south of Greenland, and about midway between North America and Europe. Our next event, the first second stage engine cutoff, or SECO-1, is scheduled to take place about 5 minutes from now. While we wait for the next mission event, let's take a look at video highlighting the important capabilities of the GPS Block 2F satellites.
The Global Positioning System is a marvel of the modern age. It consists of more than 30 GPS satellites circling the globe over 12,000 miles above us. In tightly controlled orbits, these U.S. Air Force satellites continuously transmit their signals to Earth. An extraordinary technology, GPS enables anyone with a GPS receiver to determine their precise location and the exact time anywhere in the world, usually within a meter and within a billionth of a second.
GPS is ubiquitous. It's everywhere. It's in our cars. It's in devices that you use to determine how far you've run or ridden your bicycle.
With billions of users and countless devices, it is easy to take GPS for granted. But it is the essential platform for innovations which enables us to do everyday things like buying gas at the pump and getting directions, and amazing things like tracking ice melts and saving lives in ways that were formerly impossible.
The beauty of the GPS system is that it's available for everyone. The cost of entry for any user is simply the cost of their receiver.
Boeing helped make GPS possible. It's been the U.S. Air Force's prime contractor on 4 major programs, replacing the initial group of satellites as their service lives were completed. Overall, Boeing has produced 2/3 of all GPS satellites, more than 40 in all.
Satellites are normally built in a low volume, perhaps 2 or 3 at most, and they're usually sit in one spot, and resources are brought to the satellite.
Now, to ensure that GPS is available whenever it's needed, Boeing has changed how satellites are made. It's producing 12 new GPS satellites using a streamlined process based on its efficient and advanced airplane assembly line techniques.
Our goal is to have the highest quality.
These new satellites bring next-generation performance to the GPS constellation we all use every day. As a result, they are delivering new levels of accuracy to what is already a remarkably accurate system, and they are being built in a much more efficient way, ensuring that this essential technology is available when we need it.
Used to burn well. Chamber pressures are stable. Vehicle rates are stable. Vehicle is now 147 miles in altitude, 3,070 miles downrange, traveling at 18,800 miles per hour. Approximately 1 minute left on the first second stage burn.
This is Delta Mission Control at T plus 14 minutes 59 seconds. The Delta IV carrying the GPS-IIF6 satellite lifted off from Space Launch Complex 37 at 8:03 p.m. Eastern Time. We're now just moments away from the completion of the first of 2 planned RL-10 second stage engine burns. Let's listen in for Tim Holt for mission progress.
We have SECO. Whereas settling is on. ACS settling motors are starting their ramp to 0%.
This is Delta Mission Control at L plus 16 minutes 5 seconds into the flight. Tim Holt just confirmed cutoff of the RL-10 engine. The mission has now entered an extended coast phase, which will last approximately 3 hours and 8 minutes. Following SECO 1, the mission trajectory changes to a southeasterly heading, flying over Eastern Europe, Turkey, and Saudi Arabia. It will continue in a south-southeasterly direction over the Indian Ocean. Following a short second burn of the RL-10 engine, the Delta IV second stage will deliver the GPS-IIF6 satellite to semi-synchronous orbit over the southern Indian Ocean, southwest of Australia. Separation will take place about 3 hours and 16 minutes after liftoff, or about 11:24 p.m. Eastern Time. I'd like to thank Tim Holt for his support of the broadcast, and I'd also like to thank Lieutenant Mark McCulloch.
My pleasure, Steve.
For more information about the Delta IV, please visit our website at www.ulalaunch.com. Again, www.ulalaunch.com. We'll leave you now with another look at tonight's liftoff of the Delta IV rocket carrying the Air Force's 6th GPS-IIF6 satellite. I'm Steve Agate on behalf of the entire launch team. Thanks for listening and have a great night. This is Delta Mission Control at T-minus 10, 9, 8, 7, 6, 5. We have ignition of the RS-68 main engine. 1, 0, and we have liftoff. Liftoff of the United Launch Alliance Delta IV rocket carrying the 6th GPS-IIF satellite for the United States Air Force. The Global Positioning System provides worldwide positioning, navigation, and timing services for military and civilian users. You're now hearing the voice of Tim Holt providing launch vehicle ascent data.
Vehicle control appears nominal.